Good morning, everybody. Hope you are all healthy at home. So let us move on to the final portion of our section 9.1. So in this section, we are going to discuss about using arc length as the parameter of the vector function. So till now we had studied about using t as the parameter of a particular function that we used to discuss, and now we are going to consider the arc length to be the parameter of the vector function. So in the previous session we had discussed what is the formula of length of a space curve. So if r of t is a smooth function, then the length is given by s is equal to integral a to b magnitude of r dash of t dt. Now to depict the concept of using arc length as a parameter, let us go for an example. Now we'll do example 9. Now in example 9 we are considering the function which was given in example 1, that is the vector function r of t is equal to 2 cos ti plus 2 sin tj plus t k. Now to find the arc length we must first determine what is r dash of t, then we have to find the magnitude of r dash of t. So for what is r dash of t, it would be minus 2 sin ti plus 2 cos tj plus k. Now let us find what is magnitude of this vector function, and this will be the square root of minus 2 sin t whole square plus 2 cos t whole square plus 1 square. Now what is this value? This is 4 sin square t plus 4 cos square t plus 1. Now sin square t plus cos square t is 1, we know that. So this will be 4 plus 1, and which is root 5. Now we will apply these values to our arc length formula, and we can see that s is equal to integral. Now we have to change the parameter, so we are going to take the integral value from 0 to t into magnitude of r dash of t was root 5, and we are using a dummy variable u. Now what is the integral value? Root 5 is a constant, so the integral will be root 5 into u, where we have to apply the variation 0 to t. So this is root 5 into t. Now we have obtained s is equal to root 5t. So what is the value of t from this equation? T is equal to s by root 5. So using this substitution we can find the vector function in terms of the parameter s, and s is the arc length. So when we substitute this value in the given vector function, what will be it? We obtain r of s will be equal to 2 cos, instead of t we have s by root of 5 I plus 2 sin s by root 5 j plus s by root 5 k. So I hope it is clear. The example was pretty much simple. Now let us just recall it again. What we did was we found what was the magnitude of the given derivative of the given vector function, and then we used a dummy variable u, and we found the length s, which is equal to the limit of integration was given from 0 to t, and using the formula of arc length we found the value of s was equal to root 5t, and from that we obtained what was the value of t and substituted it into the given function. Now we can note one thing, that is the derivative of a vector function r of t with respect to parameter t is the tangent vector to the curve traced by r. So the derivative of the vector function r of t will be the tangent to the curve traced by that vector function. Now, if that curve is parameterized in terms of arc length, then the derivative in terms of the arc length will be the unit tangent vector. So they are saying that the derivative, normal derivative corresponding to parameter t will be the tangent to that particular curve, whereas the derivative when we have used the parameter as the arc length, it will give us the unit tangent vector. Now it is simple. If you use we know that arc length was given to be s is equal to integral, s was integral a to v is the integral where the value limits, and it is r dash of t dt, where r of t was our vector function. So now if we use the dummy variable u, and if we vary it from 0 to s, then we have r dash of u, instead of t we are using u, and the variation is from 0 to s. Now if we differentiate this particular equation, what do we get? We get ds will be, now differentiation of integration, we know what is it? It is basically ds by ds, differentiating this equation with respect to s. So we get ds by ds is equal to the differentiation is the opposite of integration, so we have it will become magnitude r dash of s. So ds by ds is 1, so we obtain that the magnitude of the particular vector derivative vector function is 1. So you can see that if the curve is described by r of s, that is instead of t we are using arc length as the parameter, then from the equation of the arc length and varying the curve, finding the length from r of 0 to r of s, we can see that s is equal to 0 to s magnitude r dash of u into du, where u is a dummy variable. Now if we differentiate this particular equation, we get ds by ds, that is 1, and this is equal to magnitude of r dash of s. So if we find the derivative of a vector function which is described in terms of the arc length, we can say that the magnitude will always be 1. So that's it for section 9.1. We have discussed about the vector functions, then their operations, the limit, continuity, differentiation, integration, and finally the arc length, and hope you have all understood it. So thank you. Stay home, stay safe.